Welcome. This is EDS 521. This is the first instructional session. Tonight we'll be giving an overview of the course and examining some of the different kinds of data that we look at in statistics. So want to start out by just telling you what to expect from this course, a little bit about it. It's a first course in statistics, and as such there's no prerequisite knowledge that is expected on your part other than really a willingness to stick to it and look at the readings carefully and think deeply about what the meaning of the numbers may be. Some of the terms and concepts that we'll be covering this semester are going to be old hat for some of you. Clearly they'll be review. For others it will be new information, and as such it's a different amount of work for different students. So I'd encourage you to budget your time wisely and think carefully about what it is that you need to do to be successful. I will say that it's a course that is really focused on meaning. We don't spend a lot of time talking about any of the kind of mathematical or theoretical underpinnings of the statistics that we do, but rather what is the practical importance of the interpretation. And I think if you carry that message with you throughout the course, it will stand you in very good stead. So let's take a look. First of all, we have our text, which is Fundamentals of Statistical Reasoning in Education by Ted Coladarchi and others. If you haven't gotten the text yet, you need to do that immediately. It's definitely the cornerstone and the foundation of this entire course, and having a solid command of what's in that text will serve you extremely well. The other thing that you need to make sure that you're connected with is WebCT. And presumably if you're watching this video you've been able to do that, and that's where the link came from. If you have any issues with WebCT, make sure you call CED Tech Help. Their number, I believe, is 1-877-947-HELP, but look it up on the University of Maine webpage, and that will direct you right to their helpline. So, what is the structure of the course? Well, we have the lectures, which are the video pieces that you're watching right now is one example of that. There are the readings, which are clearly incredibly important for this online version of the course. And then the third are three take-home assignments. And these three take-home assignments, as I noted in the syllabus, will comprise your entire grade for the course. So having good performance on these is absolutely critical. What are some other materials that you may need? Well, a calculator will certainly be helpful. Having kind of scratch paper and pencil will be very helpful. A couple of things that I'll address more carefully and completely as I release the three assignments. You're either going to need to mail your handwritten assignments into me, or if you have access to a high-quality scanner and you can scan them at very good resolution, then you can email them to me as PDFs or as images. We'll address this issue more completely as we get closer to assigning that first take-home homework, and we can address any questions that you have at that time. So what is it that's going to be important for you? Well, don't get behind. I can't stress this enough. The weekly lecture is really going to be sort of your interpretation tool. It's the opportunity to see the sort of sense-making that I attach to the readings that you've done. But a careful study of your readings is going to be one of the most critical features of you doing well. So if you're diligent and you keep up with your readings each week, you will, I think, stay on top of the core material that you need to understand for each successive lesson. It's clearly an iterative type of a course where what you learn early on is incredibly important later on. So the other thing is, if you need help, please ask me for it. I'm here for you, and I'm more than happy to take your phone calls or to set up times to meet with you in person or on the computer. Any of the above are fine with me. And please, I encourage you to do that sooner than later. When often I'm faced with students who at the end of the semester come to me and they say, well, I'm not doing as well as I wanted to. But by that time, it's really very difficult to make it up, and it's very difficult for them to be able to go back and relearn all of that material. So don't get behind. Stay with it, and please make sure you check in with me and ask me for assistance if you need it. One of the first things that we need to do is introduce a term which is called a variable. And a variable can be a characteristic of a person or of a place or of a thing. And it's something that varies. It's something that is not a fixed amount. So how much income you make, whether you're short or you're tall, whether you're thin or you're not so thin, these are all things that vary. They're not the same across people, and we can measure differences. Then there's the notion of qualitative versus a quantitative variable. And you may have heard the terms used, qualitative statistics and quantitative statistics, or qualitative research and quantitative research. A qualitative variable is really a variable where the values vary in kind. So male versus female, or horse versus dog. These are not differences in any kind of quantity. There's nothing that is, there's no value that's attached to those different types of animals or those different types of people, but rather they're just simply different. So in a qualitative sense, we know that there's a difference, but we can't quantify that result. Now, quantitative variables, of course, these are things that vary in magnitude. So if we think about all of those kinds of things that can go up and down, it could be temperature, it could be height or weight, any of the things that can vary numerically and have some sort of logical order to their values are quantitative variables. So if you're thinking about something and you're trying to decide, is this a qualitative variable or is this a quantitative variable, if things only differ in what they're called, but there's really no order or sense to one is greater than or less than another, it's a qualitative variable. Now, quantitative variables come in some different scales of measurement. So let's take a look at what some of those scales of measurement look like. So nominal is one of the scales, and that's the same as saying something is a qualitative variable. Ordinal, an ordinal scale is a little bit different. We don't have a fixed meaning or a value attached to an ordinal scale. So, for example, a ranking is an ordinal scale. So we go from the smallest to the largest. But that doesn't mean that each increment between them is of the same magnitude or the same value. For example, rankings first, second, or third, we know that somebody won the race, we know someone came in second place, and we know someone came in third place. Perhaps it's an auto race where the difference between first, second, and third is less than 1/10 of a second. Or this could be some other type of a race where the difference between first, second, and third might be measured in days. So first, second, and third, or smallest and largest, don't really tell us much about the underlying measurements, just about how those values compare to one another. Another ordinal type of scale is a Likert scale, and we often, I think, in research confuse these. For example, you may have seen this scale, strongly agree to strongly disagree, and we'll often actually convert these into a scale variable where we're counting the values one against another. But in truth, they're not. They're actually an ordinal scale where we just know that one is is a worse ranking than agree, which is worse than undecided, and so forth. Okay, so the next scale of measurement is the interval scale. Interval scales have use equal intervals, and they have an arbitrary 0 point. Now, on page 8 of your text, you might refer to the graphic in the bottom left corner that shows the comparison of 0 degrees and 10 degrees and 30 degrees on the Celsius scale. When we think about these, we might say, well, 10 degrees and 30 degrees are maybe quite different, or 30 degrees and 60 degrees are quite different. And they certainly feel different to us, and they have a meaningful difference. However, it's an arbitrary measure. Minus 273 degrees is actually absolute zero, that point where all molecules stop moving. However, when we plot the difference between, say, 10 degrees and 30 degrees on the full scale of temperature, we see that the difference is quite small. So it's important when you think about interval scales, understand that they do have an arbitrary 0 point, and when you look at the differences in results, remember that you're looking at them in terms of that arbitrary 0 point. Okay, so like this temperature scale. So again, the Celsius thermometer example on page 8 is a good example to review when you're thinking about this. Now the final scale of measurement is the ratio scale. We have equal intervals, and we have some kind of a true or absolute 0 point. So in the case of the ratio, this is anything that can be quantified and has some meaningful zero value. So for example, weight, clearly, height, clearly, time, arguably, are all things that we can measure in a ratio scale. So what are the implications? Well, there are a number of implications for the scale of measurement that you're considering and the way you might graph or display your data. The way you can add and subtract and multiply these things. You can't multiply boy versus dog or boy times dog, but you certainly can divide other kinds of things. So the number of times perhaps that someone has visited the doctor and their average lifespan. So we could compare those as ratio variables. So these are all important in allowing us to draw kind of valid conclusions and to select the correct sort of a statistical test. It's extremely important that you remember what kind of a variable you're referring to, because it's very easy to do things that don't make sense. And statistical software packages will allow you to do all sorts of things that are really invalid uses of data. So you as the user of data, you as the statistics person, you have to be aware of what it is you're looking at and whether or not this is a nominal variable or an ordinal variable, it's some type of a scale variable, and then what kinds of operations, what kinds of statistics are permissible to use with those. So another topic that is in this first section has to do with frequency distributions. Now, frequency distributions, we can see some tables, for example, in Chapter 2, and figures of these in Chapter 3. And the purpose of a frequency distribution is to communicate information about a set of data. So they're pretty straightforward kinds of guidelines about how to create a frequency distribution. People don't create these by hand anymore. They're really generated by Excel or SPSS or some other kind of statistical software or database software. What we want to know is, how many of different things are there? And it's just about counting. How many people at a certain score level, how many people at a certain height, how many boys, how many girls completed college, how many boys completed college, okay? All of these kinds of questions are the subject for, or are best reflected, through some sort of a frequency distribution. So let's look at some examples. So it can be in tabular form. So for example, in tables 2.6 and 2.8 from your text, you can see some examples of what those look like. And so here we can see we have our score limits, and we have F, or frequency, and then the percent. Now, notice that this is the actual percent, not the cumulative percent in this particular table. All this does is allow us to visually, by eye, scan down through and see, do we have a whole lot of people here at the very top? No, not so much. Do we have most of the people here at the very bottom end? No, not so much there either. In fact, we see we've got quite a few people here in this score range, all the way through, say, this score range, 60 to 64. So this type of a tabular output, very simple. I mean, this is not complicated, but it's very important, and it's something that as you get into doing statistics and working with numbers all the time, it's easy to forget to stop and take this time to look at something as basic as a frequency distribution. So, for example, notice here that most of our scores actually fall in the middle range. Well, that's pretty good news because as we want to plot this data more, we can see that in fact we have most of our students performing sort of in the middle. Now notice the difference. Over here I plotted, what are these? Are those percentage correct? No. These are the raw score points earned. So this would be, remember, 96% to 100%, right? And a frequency distribution in the form of a histogram is really a very simple way for us to kind of visualize what it is that we're seeing. One of the things I'd caution you about is to make sure that you pay close attention to the metric. So in this case, notice that we switched from percentages to the raw number of points correct. It's very easy to lose track of what the underlying information is. So remember, in this case, 48 equals 96%. Okay? It's important to look at those details. A frequency polygon is the same, communicating the same information, but it's connecting just a series of points, averages, if you will, across our different categories and connecting them, generally connecting them with a line, just to help us see better the shape. Sometimes the underlying histogram might or might not be as easy to see or visualize as a frequency polygon. So what about the shapes of distributions? Well, the reason that we look at a frequency distribution is to understand or to capture what is the shape of that distribution. Now, if you don't plot your data, you can't see the shape. So it's incredibly important to make some kind of a tallied frequency distribution or a histogram of some sort, or stem and leaf plot, or some other method of visualizing your data. If you don't, you run the risk of not picking up on a significant pattern that you could have caught by eye. So, is the shape what you expected? Okay, and we'll talk about what the shapes might be in a moment. If it's not, what are some possible explanations for that shape? And then what are your implications? What are the implications for statistical analyses? What kinds of things are you going to want to know as a result of the visual pattern that you've detected in your distribution? So there's three general shapes of distributions. There's the normal distribution, which I'm sure you're all familiar with. So this is a great example. Here's the ACT scores in mathematics, and you can see that we have a clustering of our students in the middle. Okay? The highest point of the normal distribution, of course, is the mean, the median, and the mode. So it's the average score, it's the most frequent score, and it's the middle score. So we would expect to see a peak of our scores here in the center. And then gradually we would expect these to taper off as they get further out towards the tail. Now, this is an interesting piece right here, and some of you have probably already noticed it. I'm going to leave that alone for now, but we're going to talk about floor effects and ceiling effects later on in the course. We can also have what are called skewed distributions. They can be positively skewed, meaning that the bulk of the scores are trending towards the upper end, but our most common scores are at the bottom end of the distribution. Or they can be negatively skewed, where the longer tail of the distribution is extending down, but most of the scores are actually at the top of the distribution. So to be clearer, let's look at what those look like. So a negatively skewed distribution, as you see, most of our students are doing well, but the tail, if you will, is extending down towards the bottom of the distribution. Okay? Positively skewed distribution is just the opposite. Most of the scores are in the poor range, with fewer of the scores extending upward. That's a positive skewed distribution. We also have what are called bimodal distributions, where this could be average heights, for example, for females and males. Okay? It wouldn't be offset this far, depending on what our underlying metric was, but probably not. But this gives you a sense of we have two different groups that are reflected. And when you see a bimodal distribution, it's generally a pretty strong indication that what you actually have are two distinct groups that you're measuring on some common trait. So, for example, height and, in this case, say gender. So this could be also something like scores on a math aptitude test. In this case, we have English majors, perhaps scored as a group lower than physics majors on the right. Okay, again, the groups vary in some underlying characteristic. So what sort of a group, what sort of a distribution would this be? Well, there's a couple of interesting observations here. This is the SAT, or the Scholastic Aptitude Test data, which all 11th graders are taking now in the state of Maine as their high school exam. What we see in this case is that we have a fairly normal distribution. Most of our scores are in the middle. They're trending to be fewer scores towards the upper end of the distribution and fewer towards the lower end of the distribution. Now, there's one interesting phenomena here, and again, this is what's called a floor effect. We had a lot of students in the state of Maine in that year who scored the lowest possible score on the test. Now, we'll talk more over the course of the semester, or the course of this class, why that might be. But I'd like you to think about some reasons that that might be. Why would we have a large proportion of students earning the lowest possible score? Now, I will tell you that this spike at the bottom score does not occur on the national data set, only for Maine's data set. Now, some of you may have taken a course with me previously, and you probably have a pretty good idea. But this will be a question that I'll be posing maybe in the online discussion board. So take a look for that, and we'll kind of try to flesh that out a little bit more about this idea of whether a test matches its constituents, in this case the SAT for all Maine students. Just a couple of more slides here. I think one of the other distinctions that we need to draw is the difference between descriptive and inferential statistics. Now, what we've been talking about tonight, and we'll be talking about for the next few weeks, are descriptive statistics. These are the basics. Now, just because they're the basics, though, oftentimes I think that people automatically jump to believing that inferential statistics are superior. Well, these are qualitative terms. Okay? Descriptive statistics and inferential statistics are merely different by name. One is not better than the other. Inferential statistics are not superior to descriptive statistics, and descriptive statistics can actually tell us a whole lot more about what's going on. If you learn to really use frequency distributions, looking at the skew of distributions, looking at the mean, the median, the mode, thinking about what are the most common scores, and kind of trying to reflect on why those might be, you're actually going to be superior at using data for practical purposes than the person who's immediately jumping to inferential statistics as their lens for the world. So I would encourage you to really pay attention in this first section of this course, because although you may well know what descriptive statistics tell us, using them to really ferret out the meaning within data that we're examining is absolutely critical. So we use descriptive statistics to portray our data, to look at measures of central tendency, things like mean, median, and mode, to look at how much variation there is in our data, what kinds of, what are the standard scores that we can generate based on the distribution of scores or the differences in individuals as they perform within a set of scores. And then what is the correlation between specific aspects, say, of one test and another, or of a child's GPA in high school versus their performance in college. These are all descriptive kinds of uses for the data, and they're all very important. Now, we'll also be covering in this course inferential statistics. These are hypothesis testing kinds of statistics. Is the difference that we see statistically significant? So if boys are 3 points higher than girls, is that statistically significant? Or is it just simply a 3-point difference? So in that, we're going to look at probability and Z and t-tests, as well as interval estimation, analysis of variance or ANOVA, and chi-square. Okay, so what is the role of statistics in research? Well, we know that research starts with a substantive question. That leads us to a statistical question, which leads us to a statistical conclusion, which hopefully will lead us to a substantive conclusion. So, an example. Is mathematic problem-solving ability related to spatial reasoning ability? It's a good question. So, how do we measure this? Well, one way we might make an inference about this is we could compare scores on mathematics problem-solving ability test to scores on spatial reasoning test, and we would expect to see that they correlated positively. So then we can ask, we can look at our statistical conclusion. So that's our statistical test or question. Do those scores correlate positively? And if they do they do so significantly? Then our statistical question, box 3, is there a statistically significant correlation? So in this case, we see that we have a measured positive correlation of R, or Pearson's R, equals plus 0.65, and that the probability of this happening by chance alone was less than 5%. P is our alpha, is less than 0.05, between mathematic problem-solving ability scores and spatial reasoning scores. So then, based on this, we can draw a substantive conclusion. Mathematical problem-solving ability is related to spatial reasoning ability. Now, okay, so one of the things that we're going to challenge all the way through this course is this jump between this statistically significant outcome and us making a substantive conclusion based on that outcome. Because there's a large difference between finding an improbable result and it being meaningful. So we're going to continually question and challenge these things. I'd encourage you, if you have any questions about today's lecture, to email me or pose questions online. I'd be happy to respond to those, and look forward to seeing you again in the next session. Thank you.